Hi everyone, this is another video, class 12 mathematics, chapter 1 relations and functions. Till now we have completed different types of relations, and now we'll be learning equivalence class and different types of functions. Equivalence class. Let R be equivalence relation in A and A belongs to A, then equivalence class is defined as set of all those points, elements of A which are related to relation R, It is denoted by A. You call it equivalence class of A. Got it? So what it is saying, how it is defined? The elements of A related to R. Okay, we'll see. When we study the example, we'll understand more what that term exactly means. So this is clear to everyone. Next, relation R in set A and the elements are 1, 2, 3, 4. Consider R equal to x comma y such that x minus y is even. xy belongs to A. X minus y is even, that is difference of x and y is even. So we have to find the pairs in such a way that when you find the difference of x and y, it should be even. So all such pairs we have here. You can check in random, you check any one. First one will check and the last one will check. 1 minus 1, 0. 1 minus 1, 0. 0 divided by 2, divisible, right? So this pair is there. So when we check, it is reflexive as well as symmetric and transitive. Got it? So hence finally we can say R is equivalence relation. You getting it? I guess from the previous video you all have understood this reflexive, symmetric and transitive. Reflexive, symmetric and transitive. Equivalence class of 1. See, when we find equivalence class of 1, what we do is, here 1 will be as a second component of a pair. 1 will be second component of the pair. We'll see. In a relation R, where all 1 is a second component. See here 1 is at the second as a second component. And along with that, what is the value of x? 1. Getting it? You're getting it? Okay. So here what we are seeing is how x is related to 1. So 1, here it is related to 1. So 1. Next, we have here 1. It's related to 3. 3. Here and related to 5. So we have 1, 3, 5, which were related to this 1. Next we'll check equivalence class for 2. So 2, here we have 2 and 2, here we have 4. So 2 and 4 are related to 2. Next 3. For 3, yes, here again we have 3. Then along with 3 we here have 1 related to 3 and here we have 5. So I guess no doubt how you find the equivalence class of A related to X. Getting it? Okay. Any two equivalence class are either disjoint or identical. Now here we have 1 and 2. Equivalence class of 1 and equivalence class of 2. They are disjoint. Why they are disjoint? Because nothing is common in them. When we say identical, then they have the same elements. See, 1 and 3, they have same elements, right? 3, 3, 1, 1, 5, 5. Okay, next we'll move on to different types of function. We we have three types: 1, 1 or injective, onto or surjective, and the third one is bijective. First one we'll learn 1, 1 function. A function f such that x to y is said to be 1, 1 or injective if images of distinct elements of x under f are distinct. That is, for every x1, x2 belongs to x, f of x1 equal to f of x2 implies x1 equal to x2, otherwise f is called many one. Merely reading out the definition, no one will understand. I'll first work out the example, then you'll understand more how the definition is. Okay. I'll just show one relation and then I'll relate it to the definition. Here 1 to A we have relation, then we'll go for 2 to C, 3 to B, 4 to D. Okay. If this is a x and this is a x2, so this is the first set. Okay. See, if the image of distinct elements of x, distinct elements of x, 1 is distinct, 2 is distinct, 3 is distinct, 4 is distinct. So they are having images, they are having distinct image, that is distinct, one image. 1 is having A, that is one image, 2 with C, 3 with B, 4 with D. So they are having distinct images. Getting it? Here E and F is left out. That is not a problem. But from this set, each and every element should have a distinct image in this set under F. Getting it? Okay, this is our 1, 1 function. So here F is 1, 1 function. We'll go for one more example, then you'll understand more. See, 1A, 2 is also A, 3B, 4E. Is it 1, 1? Is it 1, 1? No, this is not 1, 1. Why? Because 1 is having relation with A, image A, and 2 is also having the same image A. What our definition says, it should have distinct image. Distinct element should have distinct image. Here 1 and 2 have same image, right? So from here itself we say that this is not 1, 1. Okay. When it is not 1, 1, what it is? It is called many one. Clear? When it is, see, if it is 1, 1, it should satisfy this condition. When it is not 1, 1, otherwise F is called many one. So this one is many one. Okay, we'll go for one more example. Okay, we'll take one more example. 1 to A, 2 to B, 3 to C. See, here we have 1 A, 2 B, 3 C, but 4 is not having an image. What they are saying? If the images of distinct elements of X, they should have distinct image under F, right? But 4 is not having any distinct image. So this is not 1, 1. Next, in a simple way, we will say this one, 1 to A, 1 to C, 3 to D, and 4. Can you say this 1, 1 or not 1, 1? Yeah, it is 1, 1. 1 is have image A, 2 C, 3 D, and 4 with B. So each distinct element is having image under F distinctly, right? Okay, so this is 1 1. Got it? Clear? Okay, our next topic is onto. You can also call surjective. A function f such that x to y is said to be onto or surjective if every element of y is the image of some element of x under f. That is, for every element y belongs to y, there exists an element x in x such that f of x is equal to y. So here what they are telling is each and every element here, every element in y should have a pre-image, should have a pre-image in x. Every element of y should have a pre-image in x. We'll take the same example, you'll understand in a clear way. See, here A is having pre-image in x as 1, B with 4, C with 2, D with 3. Is any of the element over here is left out? No, none of the elements are left out. They all are having pre-image in x. Now we'll see over here. See, A is having pre-image 1, B is having 3, C 2, D 4. But here E and F are left out. So this is not onto. This is not onto. But this is both 1 1 as well as onto. Should remember that in surjective, your y set should have, the elements of y set should have, each and every element should have a pre-image in x. None of the elements should be left out. None of the elements should be left out. So here in this case, all are having pre-image. But here in this case, see, they are having pre-image for 4 elements, but remaining 2 elements they are not having. So in this case, what do you call is this F1 is 1 1 but not onto. Here it is not 1 1, not onto, but it is many 1. F3 not 1 1, not onto, not many 1. Here in this case, F4 is 1 1 onto, and one more case is there, that is your third function. When a function is both 1 1 as well as onto, then that function is called bijective function. That function is called bijective function. Okay, now let us move on for an example. Okay, here we have another example from the textbook example I have taken. Let A be the set of all 50 students of class 10 in a school. Let f such that A to n be function defined by f of x is equal to roll number of student x, roll number of student x. Show that f is 1 1 but not onto. 1 1 but not onto. That is, x should have distinct image under f, right? Okay. A, 50 students of class 10 in a school. What is a function? A to n. What is f of x? Roll number of the student x. Roll number of Ali. Roll number of Sham. Getting it? F of x is equal to roll number of a student. Clear? So yeah, A is in the form of roster form 1 2 50. Is it clear? And n, that is natural number 1 2 3 infinity, right? Okay, so I form the set You have any doubt? No. So let us see how it is 1 1 and not on 2. Okay. Roll number 1 goes to the first student. Roll number 2 to 2, 3, and likewise 4, then 50. Do we have from set A any matching, any image to 51? No, because set A consists of only 50 students. Set A consists of only 50 students. You're getting it? So, only for 50 students we have distinct image. Getting it? Here 51, 52 is left out. So, we can say this is 1 1 but not on 2. Got? Did you all understand? Okay. Now let us move on to one more example. Prove that the function f r to r. What is this r? Real numbers, okay. Real number to real number given by f of x is equal to 2x is 1 1 and on 2. 1 1 and on 2. So we have to prove both 1 1 as well as on 2. Okay. Let x1, x2 belongs to r. This is a mathematical way of presenting your 1 1 function. Okay. F such that r to r f of x is equal to 2x. F of x1 equal to f of x2. So what is f of x? 2x. So if it is f of x1, how will you write? 2x1. That is what here written. 2x1 equal to 2x2. Next, 2 gets cancelled. So we have x1 equal to x2. Let us check how it is 1 1. So minus 1 equal to minus 1. 0 equal to 0. Half equal to half. 1 equal to 1. So I guess like this all the relation will have the images, right? From this r to this r. Yes. So f is 1 1. Next y on 2. Let y belongs to r. This is the mathematical representation for on 2. Okay. Always when you start with on 2, you have to write this. It depends on what type of set it is. Here it is a real number, so you have written r. And for 1 1, you're supposed to write this form. This is very important. Don't forget to write this part, okay? This part, don't forget to write. Should remember to write this part. Okay. So, f of x is equal to y. 2x is equal to y. What is f of x? 2x. 2x equal to y. X is equal to y by 2. Okay. If y is equal to, can take any value, we'll take 1. If the value of y is 1 by 2. See. Okay, if it is 2, it will become 1. It is 3 by 2. So do you think all here the element will have a pre-image to here, to this set? Yes, all will have the pre-image to this set. So we can say f is on 2. Did I explain about bijective? If your f is 1 1 as well as on 2, you can say that function f is bijective. Bijective function. A function f such that x to y is said to be 1 1 and on 2 both is bijective. Is it clear? So from the previous example we have understood how it is bijective. If that function f is 1 1 as well as on 2, then hence the f is bijective. So I hope you all have understood today's lecture about equivalence class. Then different types of function, that is 1 1, on 2 and bijective. Thank you.